Hi students, in this video we're going to be talking about exponential functions and in particular how to evaluate them. An exponential function is just a function, but the inputs are going to be plugged into the exponent. That's the only thing that's special about these. Well, there are plenty of things that are special about these, but that's what defines them, is that your variable is in the exponent. So we say an exponential function f with base a. So as usual, when we write an exponent, we think of this piece as the base. And when we write an exponential expression, it's denoted by f of x equals a to the x. And a is not going to be 1. 1's not interesting because anytime we raise 1 to a power, we just get 1 back. And a should be greater than 0. X can be any real number. So another way to say this is that the domain is R, all real numbers. We can plug in anything we want for X. So here's an example. If my function is f of x equals 2 to the x, then 2 is the base, and I'm going to be plugging values in for x in that exponent. So what you've seen before is evaluating this type of function when x is an integer. You're used to that because that's just going to be 2 raised to the 1. If we try to do f of 1, plug in 1. And what do we get? Well, 2 to the 1 is just 2. Because anytime we raise something to the first power, we get 2. F of 2 is going to be 2. That's our base. We plug in 2 for x, so that's 2 to the 2. And that gives us 4. 2 squared is 4. What's new is that now we can raise 2 to any power we want. The domain is all real numbers, so I can do 2 raised to the 1.756. Now I can't really do this one in my head like I could before, but as soon as I have a calculator, I can suddenly evaluate this. So I'll do 2 raised to the 1.756, and what do we get? 3.3776. 0. And we'll stop there. I could also do f raised to the f of negative pi. So I'm just going to plug in negative pi, 2 raised to the negative pi. So again, this you couldn't do in your head. It's even more interesting than the previous example because pi is an irrational number. So we can even plug in crazy things. I do 2 raised to the negative pi. And I get 0.1133. So these are really special. They're actual real live functions. We just take a base and raise it to any power we want, whether it be negative, positive, fractional, irrational, or integers like we already knew how to do. These examples show that we can take even more interesting bases. Our base doesn't have to be an integer either. So if my function is f of x equals 0.68 to the x, then to evaluate f of 2.75, I just take my base, which is 0.68, and I raise it to this power, 2.75. I have no idea how to evaluate that in my head, and so I go back to my trusty calculator, 0.68 raised to the 2.75. And we get this lovely number, 0.3462, let's round that up to 6. So these are just some examples of evaluating exponential functions with both integer bases, fractional bases, and evaluating at integer values and non-integer values. So there's one very, very special exponential function. It's the exponential function where we pick the base to be e. This is the natural constant, or the natural base, And for right now, we're going to leave it as sort of a black box. You'll learn a lot about it in calculus, but what's important to know is that it's just a number. So if you find E on your calculator, it's right here, written in blue. And if we press second E, so now I have it appearing in my calculator, and enter, it actually gives me a number. This is the value for this special constant. So E equals approximately 2.718281828. It looks like there might be a pattern here, but it turns out that E is irrational. So this pattern does not repeat. So it's an irrational number, and it has a lot of special properties that, again, you'll study more in calculus. But let's just evaluate it, evaluate the function e to the x at some specific values. So for example, f of minus 2 is going to be e raised to the minus 2. So you could think about this as this is going to be approximately the same thing as if we did 2.718 raised to the minus 2. But our calculator can be more precise. So we will actually plug in e as our base. So if I do second e raised to the minus 2, I get 0.135335. And let's just do the estimate to see what we get. 2.718 raised to the minus 2. It's pretty close. It's 0.13536. So the reason I wanted you to see both is that I really want to emphasize that e is just a number. It's not a variable. So in this function, e is our special base that represents this number, and x is the variable. So we're still plugging in for x. Let's do one more example, or two more examples. F of minus 1 is going to be e to the minus 1. And so we plug in e, and we raise it to the minus 1 power. And that's going to give us 0.367. Another way we could have done this one is just e to the minus 1 equals 1 over e. That's our rules of exponents. So if we do 1 over e, we should get the same thing. And we do. And finally, f of 0.25 is going to be e raised to the 0.25. And we'll go ahead and plug that in. And we get 1.284 approximately. So this is the basics for how to evaluate exponential functions. Most of the time you'll be using your calculator, but sometimes there will be some tricks, and I'll show you a couple of those tricks in the next video.